Will you justify? I just say that the junction O is what? It's only a physical junction. It's not an electrical junction. It's only a physical junction, not electrical junction. Okay, fine. See, somehow I made a guess. I brought it, but how to justify? It may not be no. There should be some method. Say I made a guess. Some other students may break up like this. Some other students may break up. What's wrong in thinking in different way? That's all, no? Some other students may break up this. No, who is right, who is wrong? Can happen like this also. Or nothing, sir. It's still a junction. Then how many loops are there? So I think at least we should think different. There's nothing wrong. Think in the first method. The first method we'll call first method. Second, third method is what? How many loops are there? 1, 2, 3, 4. I think 6, 7 loops are there. I'll assume loop current I1, I2, I3, I4, I5, I6, I7. 7 loop currents, 7 linear equations, solve them using matrix. Okay, no problem. We can use matrices. 7 unknown things are there. I'll solve it. Then I'll calculate the current. Then I know current in this loop, this loop. Then the common current in this branch. This branch is common. I'll take the resultant current. Then I'll find out. You can do this. Absolutely, there's no problem. But what type of exam you're writing? 1 hour, 1 question, or 1 hour, 20 questions, 1 hour, 20 questions. So definitely they want you to come with not just what you learned, with acquired skills. If it is given in assignment, okay, you can try that. 7 loops are there, solving all. Okay, no. How come this both 1 and 2 also correct? Or anyone is correct? So there's a universal. There's no problem with this. What I told, assume loop current 1, I1, I2, I3, I4, I5, I6, I7. 7 loop currents, solve it. 7 linear equations will come. Take matrices, solve it. You'll get all the loop currents, then calculate current. Absolutely, this anybody, and there's no way you go wrong. Only if mathematically you're wrong, okay, fine. Otherwise, no problem. There's a universal method. Another student, there's a third method of what I showed. Student 1 did like this, student 2 did. 1, 2, 3. 3 methods are there. So among now, who is right, who is wrong? Student 3 is absolutely right. There's no doubt on him. But it will take easily 1 hour. What about 1 and 2? You go for what is a cell? Charge of a cell should be conserved, no? The basic idea of charge of cell should be conserved. What current that enters here, that much should leave. So I'll go for current distribution. You try to see. Current I is given, no? So we'll put current I1 here. I2. I3. The same I2 will come here. I2, I3 will combine and will become I1. I think similarly here also, this I1, I2. They both will combine and this will become I1. And how much of current is entering here? I plus 2I1. That much of current it will leave. Other student also will say, sir, I'll also distribute current. What is there in distributing current here? We can distribute current here also. What is there? This one. So total current here. We'll take I1 equally. So this will be I by 2, I by 2. I have space only this much. I'm writing like this. And here I1. So how much of current in this region? I1 plus I by 2. Here I1 plus I by 2. And that current will take like this I1. This is I by 2. So how much of current here now? I plus 2I1. No. Anybody, yeah, I'm telling this one, for anybody, this difficulty will arise and we have to justify it, which is right, which is wrong. Both are right, both are wrong. Or one is right, one is wrong. Look at this branch, this branch. So look at this particular thing. This particular branch, no, it is directly connected to cell. Directly connected to cell. See, it is all techniques, huh? How the rules are made by making observation of different cases. The rules are made. I think you know standards of mathematics. How do we make rules in mathematics here? When you apply that and when they become uniform in all the cases, then it become rule. No, the same thing. So when circuits came, no, the different types of circuits they have worked out applying KCL, KVL, other thing. Then they made some observations. Then when the observations have become common in almost all situations, then they made that as a rule. So there's a branch which is directly connected. You can see that there's a branch. It directly connected to the cell. So a branch which is directly connected to the cell should not get cut, should not be intercepted. So I didn't disturb you. You can see this one. Or you can see that one later on paper in a lab. No, I'll just connect one ammeter here and here. I'll get the same current. Sir, here also I'm getting same current. You can question in that way also. Then what I do is like I will connect ammeter here and here. How the direction of current here current is like this, here current is like this. But in the lab, what it will show two ammeters. It will show current in same direction. So they show that the current will not flow like this, will flow like this. Then what they brought is, okay, this is what happening. See, all these are made by after verification. Since we don't do lab, no, we are sticking on to certain rules here. So after this, what I do, I'll draw a symmetry now. I will draw a line, symmetric line. Then the symmetric line passes through a junction. Symmetry with respect to what? Symmetry with respect to current distribution. You can see this. The symmetric line passes through a junction. So therefore the junction is only a physical junction, not electrical junction. Then it has to be separated. Because again, this branch should not be intercepted, especially this particular branch I'm saying. So I don't know this, how far JEE Advanced will entertain such problems. So it's only a physical. It's a physical junction only. This is a wrong thing. Huh? This is correct. No. What was our question? Our question is to find out further, no? The current I. I need not to bother anything here, no? So just what is I? 10 by 10, 1 ampere. Right, KVL. Go around like this, plus 10, minus 5i, minus 5i. What to do here? So what about here? Any current? Can you say anything about current here? Why not? Why I'm not dividing I1 by 2, I1 by 2? Why I should do it? So here a current will flow here. A current will flow here. This one, this current will flow. So now the current in this bench will be different. That's why I just made it different. Whether this will charge or discharge, how do you can say? For that we should write loop equation. So how many unknowns are there? I1, I2, and I3. So write one loop equation. First you write one loop equation here, then one loop equation like this,